Good morning. So let us, as usual on Mondays, go through the homework problems. Uh, Let me read the first problem for you. Consider the following quadratic equation. Yes. If this equation has a double root, then 21 minus 10 equals to, you're supposed to answer this question mark. Okay, so that is, I think, a simple problem. It's not a hard one. It's according to what we had, some of the problems in the book. Do you remember? So let me start solving this. One common mistake is that you are in a hurry, don't move one to the left, and then immediately start putting the constraint for double root. But be careful about that, yes? This is not still a standard quadratic equation, because a standard quadratic equation in which you can use PQ or ABC formula demands that the right-hand side should be 0. Otherwise, the formulas will not work. And this is the only problem, so you have to be careful. If it is 0, you can immediately start. If it is not 0, you have to move everything to one side, make the other side 0, and then you're allowed to use either ABC or PQ form. So the first thing that you have to do for this problem is to write x squared minus 6x plus 3m minus 1. And it doesn't hurt in this case to put this in a pair of brackets equals to 0, because I want you to compare this with the standard quadratic equation ax squared bx plus c equals to 0. So I prefer to use ABC formula. By the way, here PQ formula is better, yes? Because I told you whenever this number is already 1 and this middle one is even, might be you're working with PQ formula is easier, yes? So do you remember what is the discriminant of the PQ formula? Is P over 2 divided by 2 minus Q, yes? You have to make your mind first. I decided to go with PQ formula, so I wrote the discriminant for the PQ formula. So if I want to have a double root, yes?
Isn't it minus p?
It doesn't matter here, because Pawan, I prefer not to do it. If I have done it before, take it off, because why should I bother? If you put minus or you don't, because of this even power, it becomes always positive. So don't let us. But for the beginning, yes, if you want to write this formula, it is important to start with minus. But here in this one, you don't need to keep the minus sign. Yes? Okay, so I want to have a double root. When do I have a double root for a quadratic equation? When the discriminant is equal to 0. So that's it. What is P in this problem, by the way? P in this problem is minus 6. What is Q in this problem? Is 3m minus 1. Yes? So this I put it here, D is equal to 0. This implies that P over 2 to power 2 minus Q is equal to 0. So I will put the numbers in. So instead of P, I put minus 6 divided by 2 to the second power minus Q. So you have to be careful to put it in a pair of brackets equals to. But that's very simple now, you see. Minus 6 divided by 2 is minus 3. Minus 3 to power 2 is positive 9. And then I open the pair of brackets by multiplying the minus sign both here and there. So it becomes minus 3m plus 1 equals to 0. 9 plus 1, 10. I move it to the other side because my goal is to isolate m. What is the answer? It's minus 10. So what is m? M is positive 10 over. Do you agree? Okay, but the question mark is not m. The question mark is this. Okay, so I go back here. So this becomes equal to 21 times m is 10 over 3 minus 10. 3, 1 times, 7 times. So 70 minus 10 is 60. So the correct answer to this problem is actually 60. So you have to just type 60 here, yes? Any questions? So it was not hard at all. Okay, so now let us go to the next problem. Consider the following equation. What is the degree of this equation? The maximum degree here is 2, but when I raise it to power 2, it becomes 4. So this is a fourth degree equation. The sum of the squares of the roots of this equation is equal to. So in principle, you need to solve the problem and then find the roots, square them, add them up, write the answer here. Yes? But of course, the main important part is how to solve this one. So, do you have any ideas how to solve? Many of you did actually when I saw your homeworks. By the way, if you don't submit the homework, I cannot write comments. I can only write comments when I close the exam, and then it would be too late. I will not have time to go backward. But when you submit, I don't know, do you know that if you submit, what happens? You can go back again? Yes, that's the whole point. So please submit and go back again, because if you submit, then the comment box will be open, so I can give a comment during the week. I will not be able to correct all so many homeworks every week, okay? Yes, please, do you have questions?
No, just
Okay, so how do you solve the problem?
att vad kallas det? Förenkla x plus 1 upphöjt till 2.
Yes, because this one within is x plus 1 to power 2. And then another power 2 becomes power 4. Is that right? Because this is, just let me write it in 2 steps. X plus 1 squared. If I ask you what this is the first one squared, 2 times the first one times the second one squared. But there is another power of 2 there. Minus 13 x plus 1 squared plus 36 equals to 0. So let me see if I'm recording. Yes, okay. But now, I think the idea becomes clear. One part of the equation is repeating itself. Whenever this happens, the idea of having the auxiliary variable is useful. Yes, what do? I would say, for example, let t be equal to x plus 1 squared. Because this appears here and there. So I will keep this one. Okay, so then I put it here. What happens? This one, I called it t, but there is a power of 2 there, so it becomes t squared. Minus 13, and this one, I called it t, so it becomes t, and then plus 36 equals to 0. But this is very simple, yes, because either I use PQ or ABC formula. I prefer not to use PQ formula for this case, because even though this is 1, this is odd. When I divide P over 2, either I have to work with fractions or decimals, which is harder, okay? So if I want to solve it using one of those formulas, I prefer to use ABC formula. But, as I told you before, now that you are in the second year, you might have a good idea how to factorize it. I myself, let's spend a few seconds to see if I can guess the numbers, because if I can guess the numbers, that would be simpler. I ask myself, can I find two numbers whose sum is minus 13 and the product is 36? And usually my recommendation is to start with 36. What are the famous numbers? Product becomes 36. 6 times 6 is one possibility, but it doesn't work, because 6 and 6, if you add them up in any way, it will not give you 13. So 6 and 6 is out of consideration. 9 and 4 is another couple that the product is 36, and 9 and 4 has something to do with 13 as well. So these are the numbers. But I have to adjust the signs, yes? So what I will do, I will write t here, t there. I ask myself, can I give two numbers, the product is 36, the sum is minus 13. The answer is what? Minus 4 and minus 9. Why? Because minus 4 plus minus 9 is minus 13. The product is positive 36. And this is equal to 0. And now you know that this is the zero product rule. The product of two unknown numbers is equal to 0. So either the first one is 0 or the second one is 0. Okay, so this means that t minus 4 is 0 or t minus 9 is equal to 0. But this means t is 4 This means t is 9. But of course, t is not my target. My target is to find x, but then the rest of it is probably simple. So what is t? If t is 4, what can I conclude? T is the name I gave to this. So this means x plus 1 to the power of 2 is 4. So how can I solve this problem? I need a number whose second power is 4. So that number is either 2 or minus 2. Do you agree? Okay, and then if this is 2, it means x is 1, or this means x is minus 3. So 2 solutions are coming from the first, and then if t is 9, what can I say? I can say x plus 1 squared is 9. The same story, so x plus 1 is either 3 or x plus 1 is minus 3. If that is the case, x becomes 2. If that is the case, x becomes what? Minus 4. So this is one of those cases that I have a 4th degree equation, and how many solutions I have? 4. This is the maximal possible number of solutions. But as you see, what is wanted? I want to find the sum of the squares of the roots. Okay, that's a very simple task to do, yes? So the question mark is what? This one to power 2 plus this one to power 2 plus this one to power 2 plus this one to power 2. So the answer is 30. Yes? Yes.
I thought you could no, you can't. No, you can't root them down.
No, you can. If one of the numbers are negative, you are right. We cannot root them, but here we can. Yes. So the correct answer that you are supposed to put in that box is just simply 30. Is that understandable? So there was not that big challenge with these problems. So I make it a little bit challengeful for the next one. But of course, I have provided you the hint. Okay, so consider the following equation. X squared plus 1 over x squared minus 4 times x plus 1 over x equals to 3. The product of the roots of this equation is equal to what? So I need to find the roots and then find the product to see what happens. But I have given you the hint because probably if you don't experience that much, the idea of getting this as an auxiliary variable is not very evident. So, but I will consider this a very standard problem considering I have given you a hint. Okay? So probably you already know what to do, yes? Because I have given you that name x plus 1 over xt, so you don't have any problems here at all, because this becomes simply minus 4t. But the whole idea of the auxiliary variable is that when you do the substitution, you shouldn't have any track of any previous variable left. So that's the whole point. Yes? So for example, you cannot put t here and say that, okay, I will have x and t together in one problem. So it makes your problem harder, not simpler. Yes? Because your original problem is a problem in one variable. If you want to substitute one part of it with t and the other part with x, you are making the problem harder. So the only thing that you have to learn or you can find is how can I write this in terms of t? Some people naively write t squared. But t squared is not correct. Yes? Do you understand that? Some people say that, okay, Bobak, when you tell me call this t, then x squared plus 1 over x is simply t squared. This is a common mistake. If you have done this mistake, you need to write a remark somewhere so that you don't repeat the mistake again. Okay? So, x squared plus 1 over x squared is not t squared. T squared is what? T squared means the whole t squared. Yes? If I call this t, and I ask you what is t squared, you shouldn't say x squared plus 1 over x squared. You should tell me the whole t squared. But the whole t squared is the squaring rule. The first one squared I agree. The second one squared, but there is one term. 2 times the first one times the second one. The people who just naively write x squared plus 1 over x squared, they are missing this term, which is essential. But the combination is now very interesting because now this will happen. What happens here? X and that x are cancelled, and then I can write it as x squared. If you don't mind, let me write 1 over x squared first. But there is one thing that is left, and that is plus 2. So if you follow the hint, you take this to be t, but be careful. T squared is this combination. But what do you need here? You need x squared plus 1 over x squared. So I hope that you agree with me. Now I can move these two to the other side. So this is t squared. Now it becomes t squared minus 2. What happens on the right? What is left on the right is this. Well, that was the only twist to this problem, yes? So if I call this t as given in the hint, then I want you to understand x squared plus 1 over x squared is not t squared, is t squared minus 2 by this analysis. Now everything is in order, so what I do, I go back to my original equation. Instead of this part, I put t squared minus 2, and instead of this part, I just simply put t. So let us see what happens. So this becomes t squared minus 2, and then minus 4t equals to 3. Do you agree? Now this is one of the simplest Ma3c equations. So how should I solve it? So this is a standard quadratic equation, yes? So I put minus 4t here. I know that I need to move 3 to the left. It becomes minus 5 equals to 0. Again, PQ formula is very good here. ABC formula is also good. But let us again practice our factorization skills because it is extremely essential for the next part of the lesson. So how can I factorize it? I need two numbers with the sum to be minus 4 and the product to be minus 5. What are those numbers? Of course, if it is taking so long time from you, okay, go back to formula, okay? But if you are good, you can probably do it faster. So can you give me two numbers whose sum is minus 4 and the product is minus 5? Yes?
Minus 5 and 1.
Minus 5 and positive 1. So positive 1, minus 5. Double check. Plus 1, minus 5. If I add them, it becomes minus 4. That's correct. If I multiply them, it becomes minus 5. But if it is taking so long time from you to guess, don't bother. Just use the formula because it will be faster. Okay, but again, by the zero product rule, either this one is 0 or that one is 0. This one 0 means t is minus 1. That one 0 means t is equal to 5. So then I have to do the same thing as I did before. I have to solve the problem once for t minus 1 and once for t equals to 5. Yes? So let us do that. If t is minus 1, what does it mean? T was the name I gave to x plus 1 over x. So if t is minus 1, it means x plus 1 over x is what? Is minus 1. Okay, so now I have to solve this one. Of course, solving this one, hopefully you agree with me, is simpler than solving the original problem. So that was the exact idea of having the auxiliary variable. So how do you think I will solve this? Yes? Yes, remember, whenever you have fraction and you can get rid of fraction, it is better to get rid of it. So if I multiply everything by x, this becomes x squared. The x that I am multiplying will cancel that x, only 1 is left. And I have to also multiply this by x as well. But then I move this to the other side, it becomes x squared plus x plus 1 equals to 0. I don't know, for example, let us use a ABC formula this time. So what is the discriminant? It is b squared minus 4ac. b is this number, which is 1, squared minus 4 times a is 1, c is 1. But what happens? It becomes 1 minus 4, which is negative 3, and which is less than 0. So what is your interpretation now? This equation does not have any real solutions because the discriminant turns out to be negative. But it was not a priori clear. You have to write this down in the exam. Okay, but there is another option for me. The other option was t is what? 5. So I will do the same thing. So I will write x plus 1 over x equals to 5. I multiply everything by x again. So it becomes x squared plus 1 equals to 5x. Then I move it to the left. So it becomes x squared minus 5x plus 1 equals to 0. Then I have to solve this one. I again use ABC formula, if you don't mind, yes? So D is B squared minus 4AC. So it is B squared is 25 minus 4 times this times that is 4 is 21. Okay, so X becomes formula minus B plus or minus the square root of the discriminant divided by 2A. This is the ABC formula. So minus B becomes positive 5 plus or minus the square root of 21 divided by 2 times A, which is 2. So I get two answers. Unfortunately, the answers are not very friendly. So that's the last twist. That's the last torture I made for you, okay? So you don't know, yeah, you couldn't have rest a little bit, okay? But let us see how it goes. We want to find the sum, no, the product, by the way. No, I was not that cruel, you know? So because I am asking you what is the product. The product is not hard, yes? There are two roots, yes? The question mark is the product because there are no solutions here, so how many solutions I got at the end? 2. One of them is 5 plus the square root of 21 divided by 2, the other 5 minus the square root of 21 divided by 2. So I have to multiply them, because the question is asking you about the product. Yes? But if I want to multiply two fractions, I have to multiply the denominators, which is 4, and I have to multiply the numerators. Of course, you can do case by case, but this, I hope that you understand the pattern. What the pattern is? The conjugate rule. Yes? So it becomes the first one squared minus the second one squared. Do you agree? But what is the first one squared? Is 25 minus what is this one squared? 21 divided by 4. So it becomes 4 over 4 is 1. Yes? So the answer that you have to put in that is exactly equal to 1. Any questions? Understandable? Let me use this as an excuse to teach you one thing, because I saw that it is in the book. It's good to know about it. I don't know if you consider, yes, we can record this part as well. There are two formulas that in Ma3c was among the exercises, and when I checked your book, it is mentioned in the middle of the text without giving you that much reason. But the problem is that the book has given it for you for a PQ formula, but that one is not the complete one. So let me just tell you what happens for ABC formula, because it always works. The problem is this. It is good to remember this. Might be in the national exam, if the question is hard, you can use this in an effective way. So what is that? If I give you a quadratic equation, and let us say that the discriminant is positive. When the discriminant is positive, how many roots I have? I have 2 roots. Let me call them x sub 1 and x sub 2. There is a very nice formula that it is common in all high schools except here, which I don't know why, and that is this one. If I ask you what is the sum of the roots, this was an exercise in Ma3c. What is the sum? Of course, you can solve, find, and add them up. But there is a very nice formula. The formula is take this number, multiply it by minus sign, divide by a. This will give you the sum of the roots, even if you haven't solved and find the roots, okay? And then there is another formula for the product, which is C over A. Okay, for example, if you knew about this, you can immediately, because what was the question, do you remember? The question didn't ask me about what the roots are. The question asked me what is the product of the roots. So if I wanted to solve this, I never do it like this because I have that in my memory. So what is C in this problem? is 1. What is a in this problem? Also 1. So 1 over 1 is 1. So that's the product. But the calculation also confirms that. So even if you don't know that formula, it doesn't mean that you cannot solve the problem. We didn't know that formula, but we were able to solve the problem. But these formulas are very, very important. It's good to know about them. By the way, it's not hard to prove them. Why? Because x1, let us say x1 is minus b plus the square root of d over 2a. This is one solution. And the other solution is the same with the negative sign, yes? These are the roots, yes? If I ask you to add them up, what do? You say that, okay, because the denominators are the same, I put the same denominator and I will add the numerators. But when you add the numerators, whatever this is, it is gone. Minus b is minus 2b over 2a, and then you simplify 2 and 2, it becomes minus b over a. So this claim was established. Yes, it's proved. Yes? But what happens? Yes?
When you're doing the same thing for the PQ formula, do you just make a 1 or?
Yes. That's why I'm saying that if you want to use this formula for PQ formula, first you have to make sure that everything is, this one is 1. And then use it based on P and Q. Yes?
Yeah.
Of course, in that case, in PQ formula, A is 1. So I do not have these denominators. But this one is P. So it becomes minus P only. And this one is Q. It becomes minus P and Q.
Yes.
But I would prefer to use this one because this is the most general case. But let me also do the multiplication and then we are done with this homework finally. Of course, this is not part of the homework. This is one part of my teaching. So I prefer to record it as well. Doesn't matter. So now let me multiply them. What multiplication means? I have to multiply these two fractions. The denominators should be multiplied, so the answer is this. But when I want to multiply the numerators, I hope that you again recognize the conjugate pattern. Because I have two numbers, once added, once subtracted, and I want to multiply them. So the answer becomes the first one squared minus the second one squared. Yes? And I continue. Minus b squared is b squared. This one to power 2 is just d. So it becomes minus d over 4a squared. But what is d? d is b squared minus 4ac. So if I put it here, so it becomes b squared minus the whole thing. But that minus will go here and there. It becomes minus b squared. Minus minus becomes plus 4ac. And then divided by 4a squared. Now b squared and b squared are gone. So it becomes 4ac over 4a squared. 4 and 4 gone. 1a with 1a gone. C is left. A is left. So that is why the product is C over A. Yes? Is that clear? For example, let me say that in this exercise, I have asked you to find the sum of the squares. Okay? What does it mean? Of course, still you don't need this. You can find the answers as we did here. Take the first one, square it, take the second one, square it, and add them up and simplify them. But can you do it more efficiently here? Let us say that in that problem, instead of asking you about the product, I had asked you about what is this sum. Yes? Can you see how can I use these information now more effectively or efficiently to answer this?
You do minus b squared divided by a squared.
No, be careful again. This x1 squared plus x2 squared is not x1 plus x2 squared. Yes, again. So you have to learn it once for all. Yes, you need to know that this is not correct. You know it, but sometimes you make mistakes. Don't make the mistake. That's what I'm telling you. But I can write it like this. I can write it x1 plus x2 to power 2. Of course, if I write this one, I'm just contradicting myself now, yes? But I have to compensate it to make it right. Can you tell me what the compensation is? Anyone? So of course, if I ask you, is this true? My question mark is this one. But I am not allowed to write this equals to this because they are not. But I can adjust the right-hand side so that it really matches with this one. Yes?
Minus 2x1 next.
Yes. So these things shouldn't be hard for you by now. Is that understandable? Because if I ask you expand this, what is your answer? It becomes the first one squared. Yes, you have it. It becomes 2 times the first one times the second one. You don't have it. When you subtract it, it is gone. So it is not something odd. And then the second one squared becomes that. First of all, tell me, are you happy with what I have written here?
Yes.
x1 squared plus x2 squared is not equal to this, but it is equal to that. That's what I'm saying. Understandable or not?
Yes.
Okay, but now, what is this? This is sum. And what is this? This is product. Okay, do I know the sum? The sum is minus b. Let me write here. The sum, the product. The sum is minus b over a. Can you read it from this equation for me? The sum is minus, what is b?
Minus 5.
Minus 5 over a to power 2. Minus 2 times p. What is p? P is c over a. What is c in that problem? 1. What is a? 1. So that's it. Minus minus positive. 5 to power 2, 25. And minus 2 is 20. Yes? So even if I have asked you to find the sum of the squares, you could find the solutions and then raise them to power 2, do a lot of simplifications, or you can use this trick to answer it quickly. And the answer is 20. Okay? Any questions? Okay, so let us end this homework now and continue our lesson. Yeah, please take the homework seriously, okay? Do it regularly.